Hello. Good evening, everybody. Hello. Let's go settle down. Good evening, everybody. Oh, I like it. Let's go settle down. Good evening, everybody. I am in the mountains. I can have an echo. Oh, I like it. Settle down. I am in the mountains. I can have an echo.
Hello, hello. One. Very close. Hello, hello. One.
It's like eating ice cream, right? All right. Welcome to our session here. All right. This is our seventh session, and appreciate all of you coming here. We have a good panel of speakers, and we'll talk about that. But prior to that, we start. I would like to ask. This we have been doing with the coordination of ITU and ASQ. So, ITU and ASQ. So, I don't know why mine is bouncing. Eric, do I need to do anything different? Okay. All right. Eric, do I need to do anything different? Okay. The next thing it can go is inside my throat now. So let's start. We have been doing this sessions quite a bit at ITU, and appreciate ITU doing this for us and in partnership. So I'll ask Dr. Cornell to talk a little bit about ITU and why these sessions are so useful and important to everybody. And why these sessions are so useful and important to everybody.
Dear students and dear guests, welcome to our ITU ASQ event. Thank you all for coming. I am Cornel Pokorny, the chair of ITU's Computer Science Department. This event is one of many that we have done in the past years. ITU and ASQ generated and this cooperation process roughly about 4 years ago, 3-4 years ago, and since then it has gone very well. We do these events from time to time. We invite specialists from industry and from academia who are willing to give speeches and presentations about certain special areas in computer science mostly, or software security, software engineering, and cybersecurity. And they give little presentations in those special areas in order to areas that are current and of importance and are currently under development. They're state-of-the-art in these fields. We have developed this program and it has gone very well in the last years. This is just one of the activities in our cooperation. A few words about the computer science program at ITU. ITU has been around since 25 years, and the computer science department is not really all that old, but the oldest of our programs is software engineering, a master's in software engineering. Somewhat later, we installed a computer science master's program, and about 1 year or 1.5 years ago, we started a program in information and cybersecurity. These are all master's programs. And actually, right now, but not long ago, we have started to get into undergraduate education. That is, we have submitted a proposal for a Bachelor of Science in Computer Science completion program. It is currently going through the WASC accreditation process. All our programs are WASC accredited, and the whole university is accredited. The topics of our events that we do here are, of course, different every time. This evening, it is going to be artificial intelligence. This is one of the new areas. We will talk about what artificial intelligence actually is, how it is created, how it is programmed, how it's used in various areas in our society. That can be business, that can be science, that can be medicine. It's a very, very promising thing. We will talk about all this and maybe also talk about the dangers that it poses possibly to mankind. It will be a very interesting event, and I think that's pretty much all I want to say about it. And actually, we are expecting the president of ITU to show up here and say a few words about ITU. In the meantime, let me give that microphone back to Indra, or okay, yeah.
Thank you, Dr. Cornell. I'll ask Marianne to share about ASQ, the Silicon Valley chapter, and how we started all this and where we are today.
Okay, I hope I'm on the right mic now. Good evening, everyone, and welcome. We have a really exciting program for you. Artificial intelligence is something that I think impacts each and every one of us. If we don't realize it yet, we will soon. I've been asked to say a couple words about ASQ, American Society for Quality. American Society for Quality is a global organization. It's a community of people who are passionate about quality. They use the tools, their ideas, and their expertise to make our world work better. ASQ partners with 28 nonprofit organizations around the world, groups with visions and goals that are in line with those of ASQ, National Institute for Standards, the Malcolm Baldrige Quality Award Group, tons and tons of other organizations that allow us to support the needs of the global quality community and sustain a worldwide environment for quality. ASQ is a global knowledge network that links the best ideas, tools, and experts, and we have some right here. Because ASQ has the reputation and the reach to bring together diverse quality and continuous improvement, who are champions who are transforming our world. We have over 75,000 individuals and organizations that are members in 130 countries. In the United States and globally, we have 250 geographical sections, and the Silicon Valley section is one of those. We have 25 forums and divisions that relate to specific topics, industries, like the biomedical industry, the semiconductor industry, automotive, electronics, aeronautics, you name it, and we have a fingerprint on it. We have 18 certifications that we administer and over 200 training courses. You can take a look at more about us at asq.org, and I welcome you to do that. I have one other piece of information I want to share with you. Coming soon in April is the United States Census. And the census is important to each one of us because the United States needs to count every person here. Not every citizen, but every person. So it's important for you to pay attention when you get a postcard at your residence and fill in the census. You can do it online this year, which is a new wrinkle. And some more of these brochures are down on the table there. Feel free to take one as you leave. Thank you very much, and enjoy the show.
Thank you, Marianne. Michelle, can we have the slides? Yes. So, can you go to the previous one? So I just wanted to go through the series. As we see, no, that's fine. Yeah. So today's agenda, we did the introductions. Then we'll have the fortunate of the panel speakers here. And after that, we'll take a small break and a bio break, and then get back into panel questions. So as we get into the panel questions, when the speakers, we have the panel speakers speak, I would like all of you to hold on to your questions, and we'll take those questions when we go to the panel, and so that we can have a good continuation of the presentations that the knowledge that they have shared with us today. Next slide. So this is, as I mentioned, this is the 7th series, and we started with IoT, machine learning, artificial intelligence, big data, cloud computing, virtual and augmented reality, and this is now we are going back into AI. The interesting part is that the very first one that we had when we did the IoT, at that time we had also blockchain, and that time the word blockchain and Bitcoin was, I mean, everybody was trading at $6,000 or $8,000 or whatever it was at that time. Today, nobody talks about Bitcoin, but the technology that is behind Bitcoin is what is still living, and that's where it is. So we will continue these type of series, like Dr. Cornell shared, as well as Marianne. The idea behind having these sessions is so that the emerging technologies keep on coming. There are new ones, and sometimes it's like, think of it that it is the same person with a different dress, and that's what it is. And so when we talk about quality, the quality tools remain the same. It just depends on what you are going to apply to, and that's what it is all about. So the idea here is to get the experts to come in and share with us their knowledge on the subject and how they are looking at it, where they are applying, when we have some industry experts too, and they are looking at their tools as to how they are applying it and what will happen with it. And so with that, so the question becomes, what is AI, right? Next slide. So I got this definition. It's a machine intelligence is intelligence demonstrated by machines in contrast to natural intelligence displayed by humans and other animals. So the first thought came to me is that, have we run out of natural intelligence and that's why we have to depend on artificial one? I don't know. The experts will tell us today about that. And in computer science, AI research is defined as the study of intelligent agents, any device that perceives its environment and takes action that maximizes its chance of successfully achieving its goal. So basically, at the end of the day, we are all looking at the goal that we want to achieve. So any product, anything that we are doing, there is a reason why we are doing, and we are trying to reach to the goal. Now, in the past, we did it with the human beings. Now we will take the intelligence and see how efficient we can get to that, and that's where it is. Next one. So it was interesting is that founded as an academic discipline back in 1956, while we were having our introductions, Pradeep shared very quickly that AI has evolved. I mean, it's kind of like rose, then died, then rose again, then died. Probably he will share a little bit more on that one. But that's what happens is that anytime a technology or anything comes into the picture or in existence, unless there is an applicability or there is something that supports it to make it happen, it does not happen. And that's where we are. And so today, I'm sure all our experts will be happy to share with us as to where it's going. The next one. So today, we are fortunate with us, and I will ask each of the speaker to present their own self, because I don't think I can do it justice to define, and probably if I were sit here, and probably you guys all grabbed their bio out there, but these guys have got the passion. So we have Arijit Das, who is a professor at ITU as well as an industry expert. Then Deepak Parmar, he is the head of marketing and channel management at Qmetry, and he'll talk about what Qmetry is and all that. And Pradipya Ghosh, senior director of software engineering at Intel's PSG division, but he has come back to Intel. He used to be somewhere else. So what he's going to share today is not what he does at Intel, but what his expertise are and the way he sees AI. And we are fortunate to have Dr. Neil Rowe, professor and associate chair of computer science at the U.S. Naval Postgraduate School. I'm sure he will share with us everything that he knows, but then after that, we are all secured here and we will not be able to go out, but just kidding about that. So with that, we already saw, this has been done in conjunction with ASQ, and Marianne has been heading the ASQ division all the way, and we are doing the marketing and chair. And we have from ITU, Dr. Cornell, and Dr. Michelle Liang. She is the faculty project manager and the Student Governor Association. So she now is the advisor to them. And so we have been fortunate to have these two people and very happy to work with them, and so that we can continue bringing these type of sessions to you. So with that, I'll ask Arijit to say a few words. Whichever works. You want to sit in there, or
You want me to come up there? Or?
either way?
I'll speak. Okay. Hello, testing. Okay. Some of you know me already. I'm actually adjunct faculty here. And on top of that, many new faces. So welcome to all, and happy to be in the panel. My background is, I'll start off by saying that as a non-AI person, what is my impact or my influence in my life, in my work, okay? So I did invite some of my friends, and Pradipya is a colleague, and then Neil Rowe, and I know Deepak is a student here, former student here. So my slides will show a project that I did where I had lots of data, I had to handle it. I talked to Dr. Rowe and said, hey, how could you leverage technology? So I became the data engineer. We set up a Hadoop cluster, and we managed to analyze aircraft data. So a brief introduction, won't bore you with too much. Michelle, can we get the next slide? So my background, Oregon State. I don't know if there's any alumni here. I did my master's there. When I was at Oregon State, a lot of good AI interest. Thinking Machine was a big company. They made great servers. We bought them, and I was not in the AI team, but I was envious of all my colleagues who were working on the Thinking Machine servers. And then in a few years, those machines were gone, and they were being used as shelving cabinets. So that's the rise and fall of AI that I saw as a grad school student. Fast forward, year 2000, we have lots of data, and now AI is now back. AI is the king. So we are now having lots of data. Instead of using SQL, instead of using statistics packages, we're actually using AI algorithms also, and they're going after big data clusters. So that's next. And then what is my role? As I said, data engineer. If the data is not curated, not presented, not put in a good platform, the AI experts who are trying to use the algorithms may fail in actually producing meaningful results. So next slide, please. I'll jump straight to the use case. Anybody familiar with this? As an aeroplane is flying, it's sending a lot of data. That data can be captured. It's nothing secret. I work for the US government in my primary job. There's nothing secret about this. Anybody can get a software radio, can get a dongle, can get the software, and actually see the planes flying on top of San Jose right now. It's open source. But what is available is all the data is available on the exchange. Some organization has collected all this aircraft data, terabytes of data, and it's available to the community in general. Slide. So just a quick, without going into the full details of this slide, we downloaded about 2 terabytes of data. And that's when I met Dr. Rowe's research, where he's trying to find aircraft trends on the data. So his first effort was on a laptop and desktop environment. Then he moved to a Unix server. So the student who came in, he said, I'll do all this on a what do you call, Hadoop cluster. Next slide, Michelle. So this is our cluster. So we decided to use a Hadoop cluster, and we used 3 nodes, all homegrown. I'm a computer science and engineer. computer engineer. I have electrical engineering background, so I thought, good, let's get the student to do this. So he's a very technically savvy student. We built a 3-node cluster. We use Hadoop, Cloudera Hadoop distribution, our backyard company, Cloudera, in the Silicon Valley. We use their software. We use this revision. Beyond MapReduce, we use Spark. So why? Because our data sizes are small. We can use the memory and save on disk I/O. Great. So we're trying to use the latest, greatest. And on top of that, we use solid-state drives. Why use mechanical drives when you can have a small amount of data and get the speeds? So this is our hardware. So we're going to compare that to running this on a Linux server. So next slide, please. So just to tell you that people who want to venture into this, the hardware is available. The software is open source. The application software, the operating system software is Hadoop, Hadoop Distributed File System. That's open source, and it's available as a support contract. Also, we have all the packages. The experts like Dr. Rowe, who was doing AI, have AI packages that are open source available. Those same algorithms are all coded and ready to be used as APIs. Next slide, please. And finally, this is the benchmark. So what ran on a 512 gig server, Linux server, without any Hadoop or distributed processing took like 70 minutes, or whatever the number is there, 70 minutes. And then the same thing on a Hadoop cluster takes a minute. So here's where somebody wants to use AI, if doesn't have the right data engineering, will not able to see the results on time. This is a simple example of 10 gigabytes of data. As the data grows, we are going to face these problems. So I'll just wrap up with this. And Michelle, next slide, please. Next slide, please. And then this is just a pitch. There's an event coming up. I'm active in this event. I'm presenting a few papers. Some of my colleagues are presenting. If you're interested in analytics, it's a Bay Area backyard. That buildings are the former Sun buildings bought out by Oracle. I work on Oracle technology, so this is an event where I'll speak about blockchain. I'll speak about some of the data analysis we did with Sonar Data, and few more topics. So you're welcome to check out this event. It's Analytics and Data Summit coming up in the end of February. Thank you very much.
Good evening, everyone. I'm Deepak. So, Michelle, can I have a slide, please? So before the slide comes up, I represent Qmetry. Unlike the other members on the podium here, I'm not from the technical background. I represent Qmetry from a marketing and channel sales perspective. But I've seen this use case very closely, and how it has succeeded, and how AI is impacting something which is a very high volume impact, in terms of delivering software quality. All right. Next slide, please. So here is a snapshot. What it shows is what kind of data today is generated, right? It's just a snapshot overall. You can see some devices, you can see some some numbers over there, and you can see some applications like Twitter generating 500 million tweets a day, right? And there are so many such examples, and you see a lot of in this image you will see a lot of devices as well. So just register that for now. I'll bring the concept together, right? Next slide. Michelle, next slide. And here is the here is a good interesting fact. Each of these applications, some of them a little older ones, some of them Facebook, like a new an existing app, 62 million code lines generated by them, and that's increasing, right? So that's the volume of software generated today. So we talked about data, we are talking about the software that's created today. And next slide. And here is the number of developers that are coming up in this world. So today we are nearly 25 million developers. By 2023 we will be more than 27 million developers around the world. India being the largest one producing it, but China, if you really see, is growing in numbers, and would develop in terms of number of in terms of percentage, will develop largest number of or create largest number of developers in the world. So now let me bring the overall context together, right? So the amount of code that will be generated in future will be enormous. The amount of apps created will be enormous. Amount of use cases that is created today through different applications, software application, mobile apps, are enormous. And the amount of devices, we talk about IoT, are also, humongous, right? If you see each devices that is using different software today, that is also going. So where we come in, where Qmetry comes in, we are just delivering quality. We are focusing on the QA of all this software that is generated. Next slide. So I wanted to give you the volume that is driven today, in terms of software creation. It's digital transformation. What I mean by digital transformation is, when a lot of traditional companies or new age companies are writing a lot of software that is interacting business through devices, right? Be it web, be it mobile, be it IoT devices as well, right? And that's where can I have the slide, please? Yeah. And that's what is for next 10 to 15 years. This is where largest amount of software development will happen, and this is where largest amount of QA challenges will come in, and that's what we want to address, right? And I know I've still not come to the AI part. I'll come to that. Here if you see, everybody, you might have heard of the concept of agile development and DevOps development and things like that. Now, if you take DevOps for example, you are looking at continuous delivery. The software is delivered on the go. Amazon, for example, have a 11-second testing cycle per microsite created. That's like flash speed, right? And still quality is important, because otherwise you would have cases where a lot of failures will happen. 737 Max is one of the biggest example in the recent times. It can cause deaths, right? So it's pretty important. And but now understand the kind of apps created, kind of codes created, the amount of test data that needs to be generated for that is also humongous. And that's why you also hear test automation as a concept. People are going towards test automation or continuous integration and continuous delivery. This is another concept, to improve and speed up that testing cycle, because you want to deliver the software so fast. Sometimes you really do not have time to test the software, but you need to, otherwise you create mishaps, right? And that's where we believe that AI really comes in, and I want to really talk about that quickly in next 5 minutes about it. It's a real life use case, right? Yeah. So still, while automation it's been talked about for more than 40 years now, approximately, and in last 20 years, since 2009, 2002, test automation has been talked about all across the world, but the actual adoption has been very, very low. Still, you have a lot of organizations, specifically the large organizations, who really create this huge amount of software, still using something like a hybrid testing mechanism, hybrid and automation together, right? The major challenge that they face is the test data generated is huge, but you do not have the ability to analyze the data. Humans can analyze the data, but it is so time consuming. You do not have that ability, and that's where AI comes in, right? We call that intelligent test automation, right? Next slide, please. So as I said, 16%. So the real adoption of automation across the world is just 16% at this point in time. And this is from the World Quality Report that Capgemini publishes every year. You guys, if you are interested in software quality, you should read this report. It's available freely, actually. Next slide. So, one of the interesting part of this report says that, how, what is in demand. So, when somebody asks, okay, do you want to use artificial intelligence in quality assurance? You see, large number of people saying yes to it. It's a for various use cases. Do you want to use intelligent test automation? Yes. You want to use it for cross application dashboards? Yes. And predictive and prescriptive analytics. This is one field where AI is really working well for us as a QA product company, and people are really asking for it today. Next slide. So you can move to next, Michelle. Sorry. So here is the, Professor Arjit already talked about the importance of data. I mean, we hear this word data a lot, and there's enough amount of data available. Identifying and finding out, actionable intelligence out of that is what AI can help with, right? I always believe that there are three components to AI. One is data, for sure, because if you don't have data, there is no artificial intelligence possible. You need algorithms, which is the most important part, which for us, we work with multiple algorithms. And third is, the computing power, the hardware that we talk about today. AWS, for example, has a strong amount of hardware that really delivers on this AI promises. And can I have the slide? So, if you take intelligent test automation as a use case, we have data available. There are multiple softwares that create, lot amount of test data, and that can be collated. We have a software for that. Automation, as I talked about, again, it helps in generating the data. Also, it helps in analyzing that data. And then you have analytics, which is the core part where we have utilized AI. So what it does, first, the first and foremost task is it makes it easy to analyze terabytes of data, right? Not just that, applying algorithm and then finding out where the software is failing. So the idea of software testing is to find where the software is failing, and we get that on a click of a button, right? So we have AI bots which actually read into the software code generated, and the tests run on the software code, and identifying that where it is actually failing, right? And then also giving you cognitive authoring ability, where it says, okay, how you can improve this test case so that your software code would be better next time when you're generating it. And this is we also have something called self-healing, which is also AI driven, where the AI engine reads into the test code generated, and says, okay, here is where okay, certain things change in the UI, no worries, we'll find out how to rewrite that test case. So those are the things where we are using it. Very, very simple use cases, but AI is making it so simple for automation engineers and test engineers to do their job, right, with this. And it gives them a lot of actionable insight that, I don't want to focus my energy on, I'll give you one example. One of the largest bank that we work with in the US, they had 1 million test cases. That's the volume that they had for 3 apps. Okay, I'm not talking all their test apps, just 3 mobile banking apps. We went into that project, and first thing that we really found out over there was that they had huge amount of duplicate test cases, and still for each test bill they were running the same test cases. So just think about the time wasted on running that, this thing. We reduced that from 1 million to just 150,000 test cases. So that was the actual use case that we delivered using different AI based tools that we have, right? Next slide, please. I think these are some of the facts that I wanted to kind of share with you. Next, just click once. Yeah, so if you really see, there's a huge amount of cost saving, because of this time saved, and because the time to market reduced. There's a huge amount of cost saving that it brings through this AI use case. Next slide, please. And here's the overall snapshot in terms of what kind of business value it brings, because finally I'm talking from a very, very business perspective. And I've seen this for my customers. And if you see the last one, prescriptive and real-time actionable insights, that's where the AI is really creating an impact. And also cognitive authoring, you guys will hear this a lot in this is still cutting edge. This is still very few companies are working on this, but in down the line you will see this becoming like a buzzwords or like a commodity overall, and that's where AI will make them commodity, but it will be then available to larger audiences as well at this point in time, right? So you have infrastructure in terms of large clouds like AWS or Google Cloud or Azure. You have a lot of algorithms available, which these days, for example, AWS itself provides you a lot of algorithms, and there are a lot of open source algorithms that we talked about. And then you also have data which is needed to really generate the actionable insights. It's already available. So I think we are at a juncture where you have all these things available, and with right tools you will be able to take advantage of the AI technology which is available and coming up. Yeah. So thank you. Thanks for your time. Yeah.
Actually, I'll use the podium. So, hello, can you guys hear me? Good. So, next slide. Okay, so till now we heard about data. We heard about how AI can help. The next part I'm going to talk about is, can you trust it? And what will be the critical if the trust on the, what will be critical if the trust of the AI, you cannot trust the AI system, and what builds that aspect? So that's a key part I'm going to go into. Next slide. So this is an interactive question I have for each one of you. You'll ask me question later on. Let me ask you the question. The first example I have is, it's a real example. If that kind of an image is shown to a car, to a vision system in a car, autonomous car, it will not show as a stop and will tell you to go on. Could you please raise your hand as to whether you will follow the instruction to keep driving, or will you? How many of you will keep driving? Raise your hand. One. Okay. 99% people won't do that. Slide. So the next example I have over here. Oh, can you go back? The next example I have here is an application Waze inside Google map is telling you to take a longer route because there's a potential congestion up in front. How many of you will follow Waze and Google's detour? 60%. Okay. So why? Both of them are kind of similar. So what is a key aspect is, one, you don't trust, the other you're trusting. And why are you trusting? And that's the thing I wanted to touch upon and then go from there. Next slide. So this is a human psychological model of how you trust a system. And this is a key aspect of AI's trust models. And it all comes down to anything you look at and you want to believe in, there's a projection of your beliefs, and there's a projection of the explanation which a system is providing, which determines what you trust or non-trust and follow. This is very critical, and your belief on the world or the projection of your belief changes if there's a proper explanation. And that's a fundamental flaw in all the AI systems we have now. There's no explainability, no way of explaining why it decided what it decided to do. It's a black box technology. And it works in a high trust environment. In a low trust environment, or in an environment of like a regulated environment where there's liability, it will stop for working. So can I go to the next slide? So, so the explainable AI is an area of research where a lot of it is being worked on. And then there's a huge investment by DARPA, which is happening, and many other places. And why is it important? If you go into industries like transportation, finance, which is regulated, security, legal, for example, sending people to jail based upon the AI system's recommendation, Supreme Court said is not acceptable. You cannot blame the machine. Then medicine is another regulated area. HIPAA has got a lot of aspects of regulation. And in the military forces, one of the examples in a conference where I was there are drone systems which can completely autonomously work. But if you tell them to reduce casualty of your forces, the most effective way to reduce is to get rid of your forces. Think about it. Your drones are going to kill you because that's the effective way of making sure the enemy doesn't kill you. But that's learning. If you do not have explainability inside behind the AI, you cannot avoid such scenarios. So this is a very critical area where there's a lot of investment going on. So the problem which is happening is today, the model is you take AI and you take the prediction learned and you do it. But you don't know why you're doing that, why it decided the way it decided. And you will only do it if you trust it. To solve the problem, what you need to have is a explainability model. And that's what is the lower diagram out there. Explainable model and how to and the interface to that. So that if someone says that the AI system says that do this, you can say why it decided to do that. So that if you go to a law, if you're sued in the court and they say this is why did you do that, you can say this was the rationale behind it, henceforth I should not be liable. This is a key aspect of why this is very critical in a concept of explainable AI. And it's a new research area which is expanding over the last 4 years. DARPA is investing heavily since 2016, and it's being expanded, and a lot of work and a lot of advanced research is happening around here. Next slide. So now I make an assertion out here. Without this explainability, the survival of AI is kind of at a risk. Why? First of all, you cannot put AI into regulated systems without root cause analysis. A lot of the manufacturing environment, when you have a problem, you have a defect which escaped, the one thing you have to fill in is called the 8D form, which means what are you going to do to avoid such situation on quality happening ever again? And there are different levels. Is not only what did you fix, what is the root cause of it, what was the other kind of issues around it you fixed, and what is the probability, how do you say that probability of such situations is going to be significantly lower? You can't do that without with a black box AI technology. So that's one point. The second point is a lot of the governments are going to be making companies accountable. What is happening is the GDPR, EU is fundamentally saying we have access to all the data companies are going to be gathering. And California also is having similar law. Once I see the data being used on me to discriminate against me through bias systems which are using AI, I'm going to sue. How will the companies survive and deploy AI in such a scenario? That's why the explainability to get out of the legal problems or regulated industry is going to be very critical. And the third point, and this is very critical, the whole reason why we have internet technology is this law from which was put in late 90s, section 230, which fundamentally says any of the platform like Google, Facebook, and others are not liable for anything said or anything done on those platforms. There are a lot of politicians who are actually running for presidency and other positions are saying this should be removed. Once that goes, your liability goes up. How are you going to prevent your liability if you don't know what is being done over there? You cannot explain what's going on. So this is fundamentally, I believe, explainability. If you cannot explain what AI is doing, it's very high risk to put AI in your systems. And that day is coming pretty rapidly. So, so how do we bypass this problem? Because XAI or the explainable AI may take some time, may not be robust. How do you bypass the problem so that you can deploy AI? the way it is becoming popular is called Human-in-the-Loop AI, which fundamentally means the person in the loop is going to be liable, not the AI system. That's why when you have the self-driving cars, they always say you have to have a human behind the wheel so that he's liable for what happens. Most of them are basically cognitive assistant, and a lot of it is fundamentally helping users to make good decisions based on the data they have. And this is a very critical aspect of quality. Human beings cannot deal with more than 10 variables at any given time. So how do you bring the 10 most valuable variables to the human being to make the fast decisions is where AI can help. Human is going to be liable, but you improve his decision making based upon the data you present to them. So that's where AI can still survive without an explainability, because it's a cognitive assistant. It's not the solution, but an assistant to the user. So that's the whole key aspect of it. There are different frameworks and different people are working on it. So this is an aspect I wanted to talk about. I think this is my last slide, right? So at the end of the day, I believe AI is at a very critical point, just like in the late 70s, early 80s, and again, when the fuzzy logic and all the AI was going up like crazy and then suddenly went down. We are at one of those very critical points, because the regulatory frameworks are up for discussions. All the data based on which AI is based upon is becoming much more transparent. And last but not the least, the real impact of the AI is going to be more in the direction of what we call is the cyber physical space, CPS. So the interaction of human and the cyber technologies. So over there, regulation and liabilities are pretty high. So there are very interesting work going on. And in my presentation, I did put in a lot of interesting links to the fundamental XAI and other research. If you guys want to follow, read up. It's a very rich area. Thank you.
Okay, you find my slides there? Okay. So I'm Neil Rowe of the Naval Postgraduate School in Monterey here. And I've been doing AI since 1971, so I've been doing it for 49 years, which is a long time. So I've seen lots of things come and go. There have been two periods of fads. What I've been doing in that time, I first started out doing intelligent tutoring systems that used AI. Then I did a lot of stuff with data warehouses and inference in data warehouses. Then I did some work in the 80s on robotics, path planning for robotics. And then in the 90s, I did some work on natural language reasoning, natural language processing. Then in the 2000s, I was doing a lot of work on cyber deception, because that's a topic really important to the military, the whole notion of deception. And you can model it using AI. And then in recent years, the last decade, I've been doing a lot of stuff with digital forensics. So I try to keep getting into new areas all the time. So what was happening with AI in the meantime? Well, there was a big fad in the 1980s for AI based on expert systems technology. And that was basically a software engineering technology that was focused on source code. So then there was a period where they were over-promising during the 80s, and people were saying, well, AI is not going to do anything. And then there was another fad in the last 10 years, which is based more on neural nets and compiled code and things like that. So there's been two different fads. I wouldn't say, though, that the pace of AI has changed at all in that period. I think that a lot of scientific progress is pretty steady as you go on with time. And so I don't think that there's been any breakthroughs that have led to the two fads that we've seen. I would say instead that, you know, for one reason or another, things get popular sometimes with technology, and that's what's happened there. Can we go to my next slide here? Yeah, this one. So I just got two slides here. I wanted to point out some of the problems, since this is a meeting with a focus on quality in AI software. There are definitely problems with quality. And one of the reasons is that there are certain types of AI software that are just very difficult to analyze. So in contrast to the previous speaker, I'm not going to blame all of AI for some of the problems that he raised. I definitely think, for instance, there's logical reasoning methods that are used in AIs that are still quite important, and those were used in expert systems in the 80s. Also, another important thing with expert systems is humans were definitely in the loop in building those AI systems, because that was one of the key things, that you would ask humans at every key step whether they agreed with the conclusions, and if they didn't agree, then you'd go through a complicated debugging process to track down exactly what was wrong. So there's still those logical systems around, planning systems that use non-numeric constraints, like scheduling classes at a university would be an example. Then there's various types of ontological reasoning that you get when you're trying to reason about whether a product is appropriate for a particular task. There are ways you can automatically decide what's the best product that's in the marketplace to meet certain constraints that you have for a problem. So that's an example of a different kind of AI. And then there's other issues. Can we go back to the slide? Yeah, subgraph isomorphism is one of the classic problems that AI has addressed in many different forms. So if you want to recognize an airplane in a picture, for instance, something very important to the military, that's a problem of finding the pieces, but finding the pieces in the right order and connected in the right way. And so that's a logical reasoning task that can be helped. So those sorts of things are great because you can tell if you make a mistake on them. If you pick something in a picture that's not an aircraft because you mistakenly misidentified some things, you can quickly see that that's wrong. And so that was an important feature of the expert systems in the 80s, that usually things were set up so you could clearly tell when things were wrong. Now going to the next category there's systems that reason with uncertainty. And so I've done a lot of work with Bayesian systems of various sorts where you do Bayesian reasoning. And those are usually pretty easy to figure out, even though they're computing a probability of a conclusion, and you might not always know you made a mistake because the conclusion might be off by just a little. Still, for the most part, you can tell if, for instance, you've got the opposite of a factor instead of the correct form of a factor be in your calculation. You usually can tell that because the number will be significantly different. So examples would be natural language parsing now. A lot of natural language processing is very probabilistic nowadays, using probability-based methods of the likelihood of particular words, or particular senses of words, or particular grammar constructs, and a bunch of other things like that. Also, inferences from human behavior is a big topic area right now, and so those typically involve probabilities based on what people have done in the past and trying to extrapolate those to the future. So for those sorts of things, you can't always be sure you've got a bug in an AI system, but you often have a good idea if it's working generally correctly or not. And so that's helpful for quality assurance and doing things like that. But the last category are things like artificial neural networks. One of the big problems with the fad right now for artificial neural networks is they're basically a curve fitting process. They try to fit the data that they've got to some sort of a very complex mathematical curve in a very high dimensional space. And so when you do that, it's very hard to tell when you did something wrong. Now, of course, mathematically you might have the optimal thing, but what if, some adversary is trying to fool you with data? One of the things we do in the military is we fly over different areas of the world and try to figure out what the troops are doing in that area of the world. And so adversary could manufacture exercises and give false trends that we would see. And if we were building a neural net based on that, we would infer false inferences about what they're going to do based on staged activities they did for us. So there's a lot of concern with doing things like that we could be misled from. And we wouldn't know we were misled until they all of a sudden fool us and do something that we weren't expecting from the previous trends. So this is a weakness also shared by support vector machines and reinforcement learning, two techniques I'm not big fans of. I really dislike support vector machines, which were the hot topic in AI 15 years ago. Everybody was trying to use support vector machines for everything. And they're basically finding a set of boundaries to divide things up into classes. And it's easy to get confused about the boundaries and set the boundaries a little bit off and cause terrible things to happen. So I'm not a big fan of support vector machines. But I think one of the big problems with neural nets is that they're just not really set up to be able to debug very well. And debugging, I think, is the key to having good, reliable, high-quality software in many cases. Can we go to my next slide now? So the last speaker talked about explanation facilities. So I want to strike a bit more positive note and point out that there are some AI systems that can explain themselves pretty well. Some that can explain themselves sort of well, and some that have difficulty explaining themselves. So for instance, you've got, if you've got a set of rules that you're using to conclude something, one of the nice advantages of if-then rules that use logical reasoning is that if you get a wrong conclusion, you'll usually see it, so you can look at all the rules you used to reach that conclusion and see what was responsible for that wrong conclusion. So that's a key principle that they learned with expert systems in the 80s. Contrarily, if you don't get what you think is the correct conclusion with a set of rules, what you can do is look at all the rules that can be used to get that conclusion and see why they didn't fire, why they didn't apply. So there's usually a pretty straightforward approach to debugging a set of rules and giving an explanation of why they did something as opposed to something else. So then on the next level, can we go back there? Reasoning based on rules can identify the rules used, let's say, sufficiently shallow reasoning. So in the case of a Bayesian network, oftentimes a Bayesian network is what I call shallow reasoning because it's basically going to take a bunch of factors and combine them and come to a conclusion. So at each step, usually you aren't combining too many factors. I built some Bayesian networks that were complicated, but the overall 100 factors is typical of a Bayesian network. So you can look at the shallow reasoning and say, if, for instance, this number that I'm getting as my conclusion is too large, you can look at all the things that were contributing, particularly the factors that had large values, and you can blame those large values. Similarly, if the value is too small, you can blame those small values there. There's also techniques, of course, from traditional statistics like regression. So if you want to get an explanation of some numeric result, you can do a simple model, namely a linear or a nonlinear regression model, and see if you can figure out how important each of the factors was in contributing to that. So there are some ways to assign credit or blame when you're getting answers that you don't like from an AI system. Of course, one of the problems that I don't have time to go into, maybe an AI system has really got the right answer, but you're not expecting it, right? So, but in my experience, it's pretty rare that an AI system is really surprising. There are some methods in AI, though, of unsupervised learning where they deliberately try to find surprises. And I got a project right now where I'm trying to use what's known as an evolutionary algorithm that models human or biological evolution and tries to get to find a unique solution. And what we were doing was trying to find unusual vehicles that might surprise the military if they ever showed up on a battlefield. So that would be a situation where you could actually get some surprises. But for the most part, regression is a pretty good technique. Another thing you can do is you can look and see, for instance, even with a neural network, if you're getting an answer you don't expect, like you're classifying that stop sign as a yield sign, that was what was happening in that example he was showing there, you can basically look at some similar cases and see if you can find where's the boundary between cases where it's correct and where it's not correct. And you can play around with that. Oftentimes in the machine learning area of AI, it's useful to look at what are called near misses, things that are almost correct but not working, and see if you can learn something from those. So that's one good technique you can use for neural networks. Another thing you can do is, you know, often one of the concerns has been in the military that an adversary might try to fool us. So, but they're not going to pick things randomly. They're going to pick things that give them tactical advantage or strategic advantage. So it's not like we have to guess totally what they might be manipulating. We can figure out which particular things they might manipulate. So if it's an important policy decision about whether they're desirable to attack or not, that would be something that an adversary might try to manipulate. And we'll look at the neural net, for instance, if we're using a neural net, and try to make decisions about it. So there are definitely things you can do with explanation. Yes, DARPA has a project where they're trying to improve explanation facilities. But for neural nets, a lot of it seems to be rather tacked on and added on to the neural net. If you really want good explanation and good trust in your AI systems, you really need to go to something that's fundamentally rule-based or something that's relatively shallow in reasoning so you can follow what the reasoning is doing and not try to have extra complexity. Of course, one of the questions is, do we need all these really huge, complicated, deep neural nets for many of the cases now? We've been doing research for a long time in AI, and there's been a lot of successes with that. The main successes have come with computer vision, where people have be able to show deep neural nets where they've got convolutional layers, extra layers at the beginning, turn out to be really helpful. But those real great successes have only come with huge amounts of data. I deal with lots of applications where you don't have huge amounts of data, and I generally tell my students huge amount of data, a big data problem starts when you got 1 billion data items. So you need at least 1 billion data items. That's pretty hard to get by a lot of the techniques of software collection we have. Businesses, big businesses can do it, and the US military can do it with all their sensors, but it's pretty hard to do. So in generally speaking, I'm a bit critical of artificial neural networks. There is a fad for them. I think the fad will dissipate in 10 years or so, and we'll be still working with other stuff. But artificial neural networks do have definite uses right now, and they are showing lots of progress right now on computer vision, and on speech processing also is a good application for them.
Thank you, Dr. Rao. Thank you, all the panelists. I think I'll need artificial intelligence to grab everything that they said today, right? So thank you very much. Once again, let's give them a hand for all what they have shared with us. And before we take a break, we are fortunate to have the president, Dr. Gao, here, and he'll share a few more.
Thank you very much. Thank you. Thank you all for coming. Thank you, the esteemed guest speakers. I'm sure you guys have gotten a lot of great information from ASQ. I just wanted to, of course, welcome ASQ here to ITU. You guys are always, welcome to use our facilities, and also to make known to the group that, ITU, we do our best, and we concentrate our efforts to, unlike most traditional universities, we try to bridge the relevance gap between academic study and industrial workplace practices. And one of those things that we do is we make sure that our curriculum is right up with industry. So we have industry people like yourselves often teaching at ITU, kind of the latest developments, what's going on. And very recently, we've just added what we call the nugget structure, which is typical classes are 45 lecture hours. That's 3 units. So the nugget structure is 1/3 of 1 unit. So it's actually 5 lecture hours. So, friends like yourselves, if you're like, oh, wow, you're so knowledgeable, come teach a class. You're like, 45 lecture hours, plus I have to prepare the material. Sorry, yeah, I can't do it. Now you have no excuse. So we certainly welcome you to participate and author some short courses, these nugget programs, with ITU. And then also, these follow our format for quality control and assessment. So we actually can give degree credit, for these classes, and also for anything out there that we see in industry. We can tailor content directly towards what your partner institutions may need in terms of skilled labor force. And then the nice thing about that also is that we can attach degree credit to those classes that are tailored to those companies, so that for the benefit of the employees, quote unquote, the students, they can take those courses and work towards a master's degree if they choose to. So it's a win-win-win all the way around. So I certainly encourage all the partner companies with ASQ to participate more in these corporate training programs that ITU is very flexible and quick to do. And we're also flexible in where they're taught, you know, if and when. So, you know, we can teach them at lunchtime in your conference room. So we have a lot of flexibility, and we want to make sure that we are tailoring ourselves towards the industry norms and standards and trends, instead of you guys having to reach over to our, you know, so-called ivory tower. You know, so now Stanford, Berkeley, you know, where I went, great schools, but they won't do this for you. So we want to make, you know, very clear to the industry to please participate, and we welcome you to be a connective part with ITU. So thank you very much. Okay. We'll take a quick picture with you folk, if you don't mind.
Thank you very much for the few words. And in the industry, like what we talked about, that's what we need. So let's take a quick break and freshen up yourselves with some things, and then let's get back here by 7:25. All right, and then we'll start with the panel questions, and then any other questions that you all have. I think I have collected quite a few questions myself, but I think we have good, knowledgeable people that will share with us about AI. Thank you. Okay. Shall we get back? All right. Thank you guys for coming back. You know, all the panels, it's always interesting to grab the information that is shared. And this being a new subject, it's always a challenge, right? As to you don't know where it's going, how it's going. I'm sure all of you have got some questions too for the panels. But I would like to start with, you know, sometime back, a few years back, machine learning was talked about. And can you share some thoughts on what is the integration or how machine learning and AI is all going to come back together, or is there any relationship to that?
Well, machine learning is one sub-area of AI. It's always been an important sub-area back from even the 50s. People were trying to do machine learning. But important thing to know is it's not all of AI. There's plenty of other areas of AI. There's knowledge representation. You got to have some basic knowledge and a way to store it and reason about it. Then there's inference methods. And then there are application areas like natural language processing and computer vision and planning and things like that that I mentioned before. So that's something I have to explain to my students over and over again. Machine learning is not all of AI, even though there's been a lot of successes with machine learning lately, and that's why there's a lot of excitement right now just from the machine learning area. The other areas of AI are still going on strong and doing lots of interesting things, and in some ways they're helped by machine learning. As I was saying, computer vision has been helped a lot by the machine learning techniques with deep neural networks now.
You want to share something?
Well, I think you covered it pretty well. There are different domains, machine learning being a sub-part of AI. And so what are people now talking is the idea of moving from machine learning to AI. So what is the industry talking out here? So machine learning is all about you give the data, give some certain amount of parameters, and it tries to fit those parameters to get some insight and solve the problem. The way the industry a lot of time look at it is, what if I don't give some parameters or give subset of parameters, can you go beyond? That's the kind of way people loosely define AI and machine learning. But in real theoretical sense, machine learning is a sub-part of AI. The most simplest form of AI is actually, in my opinion, as you said, is if then else is decision trees. The first examples of people calling that they have AI in their systems in 2008, 2007, a bunch of decision trees under the hood. So that's kind of how I look at it.
Do you have any thoughts? No. Okay. All right. Going to looking at it, whether it is AI or machine learning, it's all based on data, right? So now a few years back, we talked about nothing but big data. So the buzzword out there was big data, and everybody was doing the big data and big data analytics, and there are a lot of jobs that were created on by the scientists, right? Data scientists and things like that. Now, can you share, and especially we have quite a few of students, as to even and people from the quality side too, is that there should be some criteria for this data, right? And what are those key elements that one should look at, or what they should have, and what does that data, which is good and bad, so how do you distinguish one and the other? So what are the criteria?
Yeah, my experience is really big data more than AI, and I team up often, Dr. Rowe, in my research. So first, you got to work with a data scientist. They know the subject matter, so get to know what they want, and then comes cleanup data. In the aircraft data problem that we posed, how much personal data do you think was bad? You worked extensively with it. Quite a large amount of the data was bad, right? Before we could actually get something meaningful. So we had to do the cleanup. So obviously, a data engineer is helping a data scientist. So the decision as to what is good data, bad data comes from a subject matter expert and the data scientist working as a data engineer. That's my take and my experience,
Okay, so I'll lead to the next question there, basically, is that, especially now that we have got a lot of students here, as well as industry, one question is that, how should oneself prepare for this new generation or new technology that is coming? What is it that they should look for? Or what should they prepare for? Or should they just decide that all the subjects that they are taking, put them away and pick up some other subjects? Or how do they prepare themselves?
I can start off and I'll pass it on to my colleagues here. So, as a computer scientist, I think I give hope to people who don't know any AI, but can still survive in the world of AI. So basically, data engineering is one. Second thing is that heavy use of computer science, in the world of data curation, getting ready, a lot of good programming knowledge. If you are not a strong programmer, SQL knowledge, and then the key thing we all miss is mathematicians with statistics knowledge. There's a spectrum of areas that a learner, a student, or a new learner, even if you're advanced in your career, you want to make a transition, if you're good in statistics, you're not using it now in job, go back and look if you can leverage the knowledge of data science and your statistics background, and you can take a career change. So there's lots of areas that a learner can leverage in this world. It's not just you have to know AI only, That's my take.
Yeah, well, I'm afraid AI is going to make it harder for software engineers because there are going to be more decisions to make, right? But this has happened in the history of software lots of times, right? When object-oriented programming came along, people had to decide whether and how far to go into the object-oriented framework for their particular application. And some applications didn't need the object framework. So there's similar things with AI. Sometimes you're going to need the AI. And so an educated software engineer is going to have to know something about what's available and whether it's going to be useful for their application. Good example is natural language processing, where it wasn't obvious at first, based on the history of linguistics, that big data was actually quite helpful. Because a lot of the time linguistics people would go to some country where there's some language not spoken by very many people, just collect sentences. They'd have a small set of data and try to reason about that. But Google, among other companies, have shown that you can do an awful lot with a lot of search terms, right? And lots and lots of text and stuff like that, and becomes an interesting big data problem that we didn't realize. So you definitely have to know something about big data techniques and machine learning and statistical testing in order to do natural language processing today. So I'm afraid AI is going to make jobs harder for anybody who builds systems.
So
Go ahead.
Yeah. So for I'm not going to make it this complex, but for us, a Python developer or somebody who has worked on NLP or working on NLP kind of makes good sense for us in terms of our kind of product development, right? So just to make it simple in terms of what kind of, and I think that for next few years, these skills will always be in demand, right? So just from the skills perspective.
So How many of you have heard about SAPFIX, SAPFIX? So this is a program which Facebook is using internally, developed. And the way, what it does is, you don't, it looks at how coding has been done before for things which have been developed. And then they look at what you are doing and tells you how to code, how to write the code. And also, first aspect where they're deploying is to automatically fix the problem. So bug fix will go away. If you take a logical sense from here, the standard software development job, which is now, may not exist if this becomes more and more popular over next maybe a decade and a half. It's going to be different. But if you go to the crux of what we do, I'm a software developer doing undergrad and then EE and systems and masters, is we take logical problems, figure out how to store and how to solve and make it useful. That's the crux of it. And if you look at all the things which is critical in this whole skill set, and that's how I interview people when I get people for AI and other jobs, is does this person know logic? Basic concepts of logic, not design logic, but logic, or known as predicate logic, mathematical logic. Does this person have the grounding in statistics? Because all this problem have a statistical aspect of it. Does this person have a grounding in operating system and has a grounding in networking and a grounding in databases? Because how do you store data? Because things are going to evolve over time, and that's where you have to bring it together. And has this person developed a skill which is deep enough in any of the other domains? Because a lot of this AI and all this computational skill we develop is basically applied skill to a different domain, like computational lithography, computational physics, computational medicine, computational linguistics. That's there. So if some student want to study a domain which is orthogonal to computation deep enough so that you have a subject matter expertise and have the grounding in different areas. As far as the languages and other things, pick it. Python is popular now. For all you know, Python may go away. Hack may be popular, Golang may be popular, something else may be popular later on. But understand what are the 4 kinds of languages: first generation, second, third, and fourth generation languages. Why and how they all come together, why they're important, where do you apply it. So that's the kind of way to approach for this future AI, because the rate of change in the way the skills you need in software engineering is going to be accelerated and changing very rapidly over next decade and a half.
Yeah, I just want to add, while listening to Pradipta, that the need for electrical and computer engineers, because now we rely on cloud services. We say, hey, everything's in the cloud. Sure, cloud companies will hire electrical engineers, but for me, in a research lab, we have data. We can't just put it on the cloud. Either we get a high level of certification. If not, for research work, we build our own clusters. We get the hardware, get the operating system, then fine-tune our network cards, so data transfer between nodes are very fast. So there's a big demand. My knowledge of as a computer engineer helps me in making these custom systems. And I've spoken in events where we speak about speed-ups and how the cost of data, cost of moving data. So I think a computer engineer has a strong role in spite of the world of cloud. There's lots of labs, research areas where data can't be moved to cloud, and they need custom hardware systems.
Question? Yes, Don.
A question for Mr. Gosh about something he spoke about, which was the trustworthy of data. This, to me, as a reliability engineer, sounds like maybe it'll work, maybe it won't. To what degree, in analyzing for trustability of the data, do you use quality techniques like FMEA, which would be very basic as part of your risk analysis? And then a question for all the panelists: to what degree does hardware or software fuzzy logic come in? That's there are chips that use fuzzy logic to make decisions. So
I can confess my ignorance. I don't know what FMEA is. What's the full form of FMEA? Oh, failure mode defect analysis. Okay.
Where you look at a particular part of the code and you look at the risks of failure, what you can do to protect against it, and how often do these defects happen?
Okay. So failure mode defect analysis, I heard FMEA. So failure mode defect analysis for on that day. Effect analysis. Okay. For the data side of things, when it comes to like manufacturing side of manufacturing, we do use it pretty robustly. In fact, what I have seen being used is how to augment this analysis using AI. Now, the other way around, the data used to train the AI system, we fundamentally what I have seen is you use the data which has been curated. And when the curation process in any manufacturing environment goes through that FMEA analysis. But this is manufacturing, this is like more of the regulated industry. In the non-regulated industry, where this is crowdsourcing, I don't have a clear understanding how that decisions are made. But I can tell you, there are some statistical models of like how to see if there's something is out of the cluster. Like you do clustering of the variables, clustering of the data set, and see something is completely outlier or not. At that point, you fundamentally have to make a decision as to, is there a gap in data or is that data bad? So that's kind of where the data cleaning aspect comes in, where using things like FMEA, I'm not really sure whether they use it for that purpose. And that's, maybe they do, I don't know.
Well, for something like automobiles, it would be like the space industry way back when they're trying to figure out why something failed. You go back to your fall trees or your FMEA to see where the problem might occur, because you've done a lot of the work up front to look to see what fails, how often could it fail, and how you can prevent it.
Yes, so you have to do that. And that was my point. Is in the regulated industry, you have the like 8D forms. You have to have the FMEA analysis, other things to show that you have done the coverage analysis and solve the problem. For like vision learning, let me take an extreme example. If government deploys vision-based credit scoring, it's happening in some countries, or vision-based imprisonment, detection-based imprisonment of activity. It's happening. And if you can sue the government for doing that, you need those kind of analysis on the data set being curated and put in there. Whether they're doing it, I don't know.
What about fuzzy logic? Is that ever used?
I don't know. I will let others answer that question. I have used fuzzy logic during my graduate research time. That was in the 90s. It was it was dying at that point, but still hot. But the only thing which I know is mostly it's in toasters and in washing machines. It's being used. The logic of like throw the clothes in and it runs is kind of, I think it's a fuzzy logic. If at least 4 or 5 years back it was that. So that's.
Any other thoughts? What was the second question? Was on the hardware and software, right?
Implementing fuzzy logic, so there are no hard and fast rules, but there's no straight line fit. It's almost more like a logistic regression in terms of the input variables and the output. And sometimes you don't always know 100%. There's some area of uncertainty.
So this is good. So I think we can have another session a year later and know how good the fuzzy became consistent. Any other questions from the audience? Yes.
Hi, my name is Daisy. I come from ASQ today. I want to ask you this because you brought up the GDPR, and United States has a HIPAA, PHI, and all these. So down the road, we have a genomic going on. So we have a lot of data that coming around. So how can we use AI technology to manipulate all the data? Or not manipulate, how are we going to analyze those? But when we are in regulated industry, we have a lot of things need to be done. So is that any AI have a thought about coming to the biotechnology? How are we going to do that?
Well, can you explain a little more what you mean? What sort of reasoning are you thinking about?
Sure. So we have, in United States, we have it governing by FDA as well. I know that in April 2019, FDA has a draft guidance coming out for looking at the AI stuff as well. So we have a lot of genomic is coming up, data collecting all these. If we're going to use the AI, how are you going to analyze those data within the regulated industry? Because we have to do a lot of validation. We cannot just analyzing. If you use the tools needs to be validated in the industry. So I don't know which way the AI is going. If you have any idea.
Well, a lot of the biomedical applications are relatively simple compared to some of the other applications. So I'm hopeful that it will be easier to regulate it because people will see what they're doing. Usually what you're trying to do is find if some factor is important for some disease or something like that. And that's a relatively simple statistical problem. It's not like building a neural net where you're going to find some subtle combination of factors that contributed to a disease. But I think that we're going to have an easier time just finding one factor that would be important and significant.
So the other use model could be is something from past experience. We had to accelerate quantum level simulation, which is which is very hard to mathematically model, but you can model it. But the runtime and computation is very high, and you have to have those computation and then solution search happen fast, which means you have to. There's a convergence problem. When you have a quantum simulation and a convergence problem, it's a very complicated. So the idea is you go to many iterations. And similarly, genomics and biochemical reactions have similar problem. What you can use is fundamentally what we did was using neural networks, deep neural networks, based on pre-trained weights to reduce the number of iteration. So because you know the constraint of the physical world, like biological world, is fixed. So you use quantum level simulation in a teaching environment to train it enough so that the neural network is learned enough so that if, say you have to do 50 iteration to converge to a solution, you can do 49 of those or 47 of those using neural network. And the last 3 is actual simulation. When you have the actual simulation is the final steps, and then you have to understand what happened, you can explain. And that's where the regulation people want to know how did you get to that point could come. That could be one use model as accelerator.
So since we are on that healthcare side, I want to get a perspective from you guys, is that lately, about a couple of weeks back, there was in the news article where AI was used for looking at radiation so that the radiologist would be out of job, pretty much, right, if the AI does the job. So where do you see AI being applied in healthcare? But then immediately some of the radiologists came back and said that whatever the AI tool was used, then whatever they analyzed, it was not correct, or it did not have the right criteria or anything like that. So where do you see in the healthcare industry AI is being applied, and where do you see what the impact would be?
You know, my take on that as a software person is that, you know, software is going to be buggy. You know, what do you do? So totally relying and saying the radiologist is out of the loop is not my take on it, you know. So I think like Pradipta mentioned, man in the middle kind of situation where there's a human and there's AI assisting. So I would say in radiology and medical systems where life and death decisions have to be made, model like shown in the slides that Pradipta had is a more viable model, because nobody's going to, whom do you sue in case something goes wrong? So I'm thinking of a hybrid approach, human-machine approach,
Let me start with this comment, always follow the money. At the end of the day, who's going to be liable, and is he insured and reinsured? That's what it all comes down to. So if there is a insurance and a reinsurance model, financial model, where the AI systems can be insured and there's a proper reinsurance behind that, then it can be deployed into a more independent way, even in medicine. Because then if there's a probability of people losing life, there's an insurance of paying for that loss of life, and there's a cost, there's a well-defined cost of what a human life in US is valued. Yeah. So that will take it to the full automation. Independent of that, it's going to be more of man in the middle, and we have been using, if you see all the automation systems which doctors use, those are all kind of is a smart knowledge or a kind of a direction towards AI system. It may be just an incremental step from there. He may have something like the little pin which is around in your lower left corner in Windows for his the ERP system which he has for the medical records, but so he gets the most relevant records to look at. The next level step could be for the image over there is fundamentally look at these 5 different places. And if there's enough reinsurance and insurance in place, then then fundamentally what will happen is people will walk into X-ray booth in a shopping mall, get an X-ray, and they will say that you're good and go away. And if not, then there's some probability we should go to the doctors. It could go to that extreme also. So it depends on this where the insurance reinsurance program is there in the system.
So follow the money, right?
Follow the money.
Yeah, I should point out that AI is really automation technology, even more so than other technologies. So lots of jobs are going to get automated by AI, but it's going to be very uneven in what areas are going to get automated. Maybe radiologists are going to be the first because they're doing something that's a relatively narrow thing focused on data, right? So, but I should point out doctors were worried with expert systems in the 80s. They were all going to get automated on diagnosis, and that hasn't happened. There were a lot of other things that are taken into account in a diagnosis that couldn't be done by the simple text-based expert systems then. So there may be some hope for professions, but that's generally what's happening is that many different professions are getting automated by AI. There used to be a lot of clerical staff in organizations, right? What do you think happened to all the clerical staff? We've got tools now that make it much easier to forward stuff back and forth. Maybe not in the federal government, though.
But you are absolutely right. Automation does help, and it does displace people, but I think what it does is that it takes the expert to apply their knowledge in a different way then, right? And how to use that data to make it better or make it more efficient, right?
Yeah, but I still think some people are going to get automated because at some point the expert will have so little to do, they'll just be pushing a button.
Okay. Any other questions from?
I would like to comment this because nowadays physician will have telemedicines. So you can across the country or you can cross the nations, you will get all the data that they can look at it. It will be advanced. I think AI will be, going around the globe. That's my hunch. Not a question, I just made a comment.
To what degree are AI-based systems hackable? For example, in an airport, a hacker could put in something in the code so that everybody gets alarmed. That's a false positive. Or it might let people pass through, even though under normal circumstances, they would have been flagged as, oh, this guy's a terrorist, we got to stop him. To what degree are you concerned about false positives, false negatives based on hacking?
Well, I'm very concerned because in the military, we're always concerned about safety. And you know, that's what my point about explainability was about, that the hackable systems are the ones that are not very well explainable. And so we have to be aware of what AI technology we're using, because some of them are definitely going to be more explainable and safer than others that are available.
So there's two dimensions of how things can be hacked in an AI system. One is through data, and that's what Professor Rowe was saying, that if you keep on feeding bad malicious data, then you just hack the system. The other way is how do you fundamentally change the algorithm or go in there and take over the system? And that becomes less of an AI problem. It becomes more of a domain which is known in this security domain called root of trust. Any system, when it starts with a BIOS and how it's loaded up. Now, if you can break that and load up with your own BIOS and get the system up the way you want, you can then put your stuff and hack it. So how do you prevent this this hack being happening? So that's the aspect, is at a system level, how do you prevent from breaking into the system? So those are the kind of things, and there are many domains which come in. One is this whole system design for security. One comes in is the security-based software development, which fundamentally comes is that as you develop the API and the algorithms and the libraries, you follow the standard security processes not to have things broken or things can be hacked, because any open door you leave, even like a bad hash or a bad overload buffer, that can be used to hack. Then, but with the AI, the secondary, the more important extra angle which comes in is you can hack through data. You can just keep feeding bad data to make the system change. If it is, if you don't have kind of a separation of this learning and the inference. So that's the other part. It can be hacked.
I mean, I just got some ideas and started to look at blockchain where decision making is decentralized. So maybe a future idea, just a thought, is combine blockchain and AI, you know, and get a more decentralized learning system.
That can be hacked too.
Okay. All right.
I just wanted to sort of piggyback on that and confirm, with all these different contingencies, whether it's hacking, other types of safety, how centralized is that with the AI research? Like, are companies and government organizations working on both? Or is it more you can outsource the AI technology and engineers and work on the safety internally? Or if you're in a non-regulated or industry, you just do the AI work and trust that the rest will be taken care of?
So the days of developing internally is over. Every company uses open source software. So when you are using open source software, how do you make sure that it is secured? That's where it all comes down. And with, most of the companies have got security policies, as it's called security development policies, and with variant names. And it comes down to a part of the process, part of the curation of the libraries, part of the curation of the data, and also part of it comes from the aspect of, at the system level, you design so that a failure or compromise at a component does not compromise the overall system. The system could be software, could be hardware and software. So that's how companies are most places people look at security and taking in our third-party software. Does that answer your question?
Yes, and I specifically was referring to the contingencies that have been mentioned that are keeping us from advancing in AI farther. So keeping the 60% of people that did not vote to apply AI in all the different areas from the earlier presentation.
That comes down to the trust aspect, right? Like how do you get trust on the system which is there, which is always with any new technology. Whenever you get a new technology, it's there's a leading people, then most people use it, and then the laggards come in, and then then there's some people who will never use it. Like I barely use any Apple product.
So you believe
So-
it's more time will pass and less companies need to work on different processes that need to be implemented?
Companies will develop that thing. Companies will become more transparent. The rate of failures will go down. And then over time, what will happen is there will come common standards and practices which become deployed. And then people will more and more trust in it. That said, in the core AI domain, I still have huge question about, as Professor Rose said, is on the neural network side of things, unless you can bring in explainability in there. And because our blank trust in internet being good, I think is over. It's at a point where people don't trust what's on the internet. And for the last 20 years, since 25 years since I've been in the IT technology and working here, by default, people assumed anything on internet is good. Anything on internet is helpful. That there was a default trust mode, and that has switched. And that's the reason I wanted to bring up this topic of trust over here. So can technologies help? Yes. Blockchain? Could be. There is a whole different blockchain about voting. There's a if you guys are interested, you should go and look at the ethereum.org and core blockchain and the variant derivatives of it on distributed trust. But that said, Ethereum network, blockchain network was hacked. So it can be hacked. Anything can be hacked. So it's all about trust. How much do you trust? That's a key thing.
Yeah, I should point out driverless cars are one good example of trust that we're going to be seeing in the future here. I've always been skeptical of driverless cars, and I think what's going to happen is they will occur and people will be using them, and then there'll be some terrible accident, and all of a sudden one little accident can make a big influence on public trust of something if it's written up in the news media and creates a lot of media stir. So that's what I'm afraid is going to happen with a number of other areas of AI. There'll be some terrible disaster, and then there'll be a negative reaction, because it's easier to get people to distrust something than it is to trust. I've written a book on cyber deception, by the way, and that's one of the topics I talk about in that book, that distrust is easier to kindle and cultivate.
Okay, great. All right, with that, it's past our time, so let's end here. And any other last moment thoughts that any one of you want to share?
So I think, in terms of any new system that is developed, I feel the failure, defines the next step, right? So take example of Boeing 737 Max, right? A good technology, it was making autopilot more, more predictable. It was making life of the, pilot easy. That was the sales pitch, right? On that entire device that was developed. 3 accidents, 3 major failures, 300, 400 people dying. The concept changed, and they were questioned. I think 100 odd aircrafts were grounded. Will it stop development in the airlines industry, or where you will have more AI driven aircrafts? No, it's still going to go there. But now you have more regulations, and people would would ask for more regulations to provide more safety, right? So it's the failure is as the adage goes, the failure is a stepping stone towards the success. I think it applies to AI as well. We'll see more failures, but it will improve the system over a period of time. I think we are seeing that in the vaccines as well. The current outbreak that's happening in China, it's again, it's a similar thing where you believed that you have vacciners and anti-vacciners and stuff like that, and you believed in that vaccines are good. They would that will secure you from influenza, and now you find new strains of viruses. It's a failure of the current vaccine, but now scientists are working to develop newer vaccines to improve the health, in terms of fighting against the simple thing as flu, right? So yeah, I mean, according to me, failure will define the next step of AI.
Great. Thank you very much. Once again, let's give them a big round of applause. Thank you very much for being here and sharing your thoughts. And let's be intelligent, naturally rather than artificially. Thank you.
I just wanted to mention on this slide at the bottom of the slide is ITUSJ. So this event can be looked up and viewed on YouTube using that search. So if you're interested in seeing yourself as the stars of the show, there you go.